Kapasia. So, guys, I will explain J.J. Thomson's modified model, which is known as Rutherford alpha particle scattering experiment. ये मॉडल 1911 में इन्वेंट हुआ था। रदरफोर्ड ने इसको इन्वेंट किया था। जैसे कि आप देख सकते हैं इस मॉडल में ये जो है ये गोल्ड फॉइल है। गोल्ड फॉइल जो भी अल्फ़ा पार्टिकल यहाँ से आएगा वो इससे स्केटरिंग करेगा। स्केटरिंग करने के बाद कुछ अल्फ़ा पार्टिकल्स तो ऐसे होंगे जो फॉरवर्ड डायरेक्शन में चले जाएंगे और कुछ अल्फ़ा पार्टिकल्स ऐसे होंगे जो 90 डिग्री से कम होंगे, लेकिन कुछ ऐसे होंगे जो 90 डिग्री से वापस चले जाएंगे, मीन्स बैकवर्ड डायरेक्शन में चले जाएंगे। जैसे कि हम देख सकते हैं इसमें, सॉरी गाइस थोड़ा टाइम लगेगा। Yeah, as we see in this figure, some particles came and passes through the gold foil, goes forward direction, but some particles are bent less than 90 degree, and some particles are bent more than 90 degree, and some particles are bent backward direction. So J.J. Thomson's, according to J.J. Thomson, the alpha particles came from a radioactive metal. Now I will explain what is the J.J. Thomson's modified model, which is known as Rutherford model. In this experiment, Rutherford bombarding a fine beam of alpha rays of high kinetic energy from a radioactive element on a very thin cold sheet. The whole arrangement was placed in vacuum because if we are placed it in a air, then the particles scattering and collide with air particles, then the direction of these particles can be deflected. So we are placed in vacuum to show the deflection of alpha particle in the different directions while passing through the gold sheet. The whole arrangement, because the whole arrangement placed in vacuum, so the air particle cannot disturb the particles which are goes forward direction or backward direction where they form an angle, whatever they form. The deflection of alpha particle from their path is known as scattering. The alpha particle scattered by gold foil. सो द रदरफोर्ड ने कुछ पोस्टुलेट्स दिए थे इस एक्सपेरिमेंट पे बेस्ड. नाउ वी आर स्टडी. अकॉर्डिंग टू रदरफोर्ड, first postulate of Rutherford is most of the particles passes straight through the gold sheet without deflection. From this, Rutherford conclude that most of the space of an atom is empty. Second postulate of the Rutherford is some particles are goes forward direction, but because there means that Rutherford checked that where's the positive charge is obtained when Rutherford scattered a particle at center, then he observed that the particle is deflected. So Rutherford conclude that most of the positive charge of an atom is placed in the middle of the atom at the center. So second postulate of Rutherford is entire positive charge of atom is concentrated in a small space inside the atom. But J.J. Thomson's believe that the positively charged distributed uniformly in whole the atom. So third postulate of J.J. Thomson's modified model, which is known as Rutherford's model, some particles deflected less than 90 and some particles deflected greater than 90. And most of the particles are going to forward direction and some particles return back, as we see in the figure. So it is clear that when positive charge alpha particle passes through the gold sea, then some alpha particles experience so much repulsion because there is positive charge at the center, and when positive charge goes to and collide with positive charge, it's so repulsion. So it is clear that positive charge at the center. From this, Rutherford conclude that entire positive charge of atom is concentrated in a very small space of center part, which is known as nucleus. From this figure, it is clear that alpha particle get deflected when they are scattered with nucleus. They experience more repulsion and is deflected by some big angle. When there goes there, the positive charge deflected more than 90-degree angle. So Rutherford calculated the distance of closest approach to nuclei of alpha particles, which is known as radius of nucleus, and found that it is about 10 to the power minus 15, which is a much less distance, and the radii of atom is 10 to the power minus 10 meter. Since in the comparison to atom the nuclei is very small, therefore the change of alpha particle to reach near the nucleus is negligible. That's why the number of alpha particles with large angle are very less. Now next postulate of Rutherford is when any alpha particle passes through the atom of gold seed, then the force of repulsion acting on it due to nucleus inversely proportional to the direct distance from the nucleus. Coulomb's law, as we know, Coulomb's law in physics, this is somewhat related to Coulomb's law. And by computing the scattering particles through different angle by the help of Coulomb's law, Rutherford found that the Coulomb's law is also meet for atomic distance. Fifth postulate of the Rutherford is Rutherford also estimate the amount of positive charge present in the nucleus of various metal through it experiment. He counted the alpha particle scattered at a definite angle by following them. So we can conclude that nucleus of different metal have different amount of positive charge, and the Rutherford model is finished. But most of the postulates, Rutherford says that entire positive charge is placed at the center, and second is most of the space is empty, and third one is most of the particles are back forward sorry backward comes backward direction, and fourth postulate of the Rutherford is the closest approach of alpha particle is the distance between alpha particle which is bounce back and the nucleus. Thus all the postulates are modified from the J.J. Thomson's postulates. Okay, thank you so much for watching our video.